and gentlemen, I would like to welcome you at this high-level debate about the potential of bacteriophages in fighting AMR. My name is Margareta Przybyła. I am Secretary General of PhageEU. As you know very well, this event is hosted by Mr. Tiemo Wölken, member of the European Parliament. Unfortunately, due to unexpected reasons, Mr. Wölken is joining us online, but we are very happy to have you with us. And Tara Hadwiger made it possible for all of us to be here. So before we will move to Tiemo Wölken for welcoming statement, I would like to hand the floor to Mr. Jarosław Gastych for very short welcoming remarks.
Good afternoon, everybody. Good afternoon, ladies and gentlemen. I would like to thank for organizing this meeting our host, Mr. Tiemo Wölken, and I hope it will be a great chance to discuss the bacteriophage technology and its application in the European Union. Please, Mr. Wölken.
This was very quick. Thank you very much. So I hope you can hear me well. And I would like to welcome you all. And I would like everyone for joining this very important event. I think it is a timely discussion as it marks the beginning of the new legislative term, giving us approximately, maybe a bit less, 5 years to pool our resources and further push this topic onto the political agenda. I have seen my colleague Mr. Schenk in the room. Please accept my apologies if I do not recognize everyone, because I can only see the three persons in front. So I know he is a champion at national level in Germany on this topic. So we already have some colleagues who are interested. And I would like to apologize that after being the host of this event, I'm not able to join in person today. As many of you might know, I became a father at the end of May. So this new situation requires a bit of balancing between work and family life. And this, unfortunately, I had to change my schedule and my travel plans, and I hope you can understand this. So, and please also, I would like to apologize already in advance if I will not be able to stay until the end, due to the fact that I would have to take care of my daughter then. So, but this aside, I would also like to take the opportunity to thank PhageEU for the help and organization of this event. So, dear Margareta, you have put a lot of work into this next to Tara, who you already thanked. So, thanks to you. Antimicrobial resistances, as you all know, remain one of the greatest public health challenges of our time, claiming over 35,000 lives annually in Europe and jeopardizing the effectiveness of modern medicine. So its economic impact is equally staggering, costing the European Union approximately 1.5 billion euros each year in healthcare expenses and productivity losses, as estimated by the ECDC and the Organization for OECD. So what I would like to say is that without urgent action, AMR could lead to up to 10 million deaths annually by 2050, making it a looming crisis we can no longer afford to ignore. And when discussing AMR, the focus often turns to antibiotics, of course, while preventing the unnecessary use of antibiotics through also increased awareness-raising efforts is crucial. We also need to accelerate the development of new antibiotics. And the European Parliament has already completed its work on the pharmaceutical legislation. We are now waiting for the member states to finalize their position, which will hopefully happen sooner than we expect. But, well, I think we might have to wait at least to the 1 or 2 years. So, but in the meantime, time is running out to implement effective incentives for developing new antimicrobials. And although new antibiotics are essential to combat resistant infections, their necessary sparing use creates an economic paradox that discourages pharmaceutical companies to invest. So our proposed incentive structures like the subscription style payment model or the milestone payments, which decouple profit from usage, could provide a viable solution, but these need to be implemented without delay. But the main reason we are here together in this room, and we were also joining you from remote connections, is not the incentives for novel antibiotics. It is to discuss the potential of bacteriophages in the fight against AMR. And phages are a promising form of medical countermeasure whose potential remains largely untapped and deserves increased research and development. Personally, I am advocating for a legislative initiative report in the SANT committee that takes a broader approach to phages, as their applications touch up on many fields. In healthcare, phages can serve as an alternative or complement to antibiotics, particularly for infections caused by superbugs like MRSA, sepsis, and chronic wounds. In veterinary medicine, phages can treat bacterial infections in pets, especially when conventional antibiotics fail, offering similar benefits to those in human medicine. In diagnostics, engineered phages could be used to detect specific bacteria, enabling more accurate and rapid diagnostics compared to traditional methods. Phages also hold promise for improving animal health by preventing or treating bacterial infections in livestock, reducing the use of antibiotics, and mitigating the risk of resistance. They can play a significant role in food preservation, being applied to food products to reduce bacterial contamination risks such as listeria in processed foods or salmonella in poultry and E. coli in meat products. And additionally, phages could be used in food processing environments for sanitation purposes, enhancing food safety without the need for harsh chemicals. In the environmental field, phages can assist in wastewater treatment by targeting specific bacterial populations, thereby reducing the spread of antibiotic-resistant bacteria. These examples underline the immense potential of phages. However, all of this requires regulation, and as policymakers, we have significant work ahead of us. Specific legislation in this field is needed, and I look forward to actively contribute to this effort during the current legislative term. I'm also pleased that today's agenda includes not only representatives from the phage community, as I would say, but also officials from the European Commission. We have representatives from DG Santé and DG HERA with us, the European Medicines Agency and EFSA. And their participation and their input is vital to advancing this important conversation. And I would already say a huge thank you in advance to everyone who is ready to contribute today. And finally, I would like to point out that PhageEU has prepared a common declaration on the recognition of the potential of bacteriophages in fighting AMR. And I'm very happy to be the first of hopefully many MEPs to sign it. If Mr. Schenk wants to leave the room without it, please stop him. No. The jokes aside, I will now conclude as we have a packed agenda and are here to hear more from our experts. So I would like to thank everyone again for joining us today. Thanks for everyone who put so much effort in organizing this event, and I wish us all a productive and informative session. Thank you very much.
Perfect. Thank you very much. Yes, we can only applaud to what has been said. Thank you very much for your introduction. We are very happy, I think, to see that you are already a true ambassador for phages and that you are ready to work on the issues. So we are very happy to work with you together on this. So thank you very much once again for your support. Indeed, the agenda is very tight, so I will just very briefly move to the first block, which is presentations indeed from the phage community. We will be indeed presenting the practical applications of phages to what Mr. Wölken has already referred. And afterwards, we will have interventions from the European Commission, European Medicines Agency, European Food Safety Authority. And at the very end, I hope we will have time for debate, because this is really about debating, interactive discussion, and I hope there will be a place for questions from the answers. So without further ado, I would move now to presentations from PhageEU. PhageEU is a coalition of like-minded stakeholders who represent phages in science, industry, and civil society. We have been incorporated only in July, so we are quite new, but we really want to be very active in the EU. And the main aim of PhageEU is to be indeed the missing link between the phage community and regulators. So I think this is the place where we are here today is really the proper one. So I will move to the presentations from PhageEU. We will start with Hans-Jörg Lehner from PTC Phage Technology Center. Then we will have a presentation from Professor Jarosław Dastych from Proteon Pharmaceuticals. And then we will hear from our colleague Frank Smreker from Jafral from Slovenia. So please, Hans-Jörg, you can start. Tara will share the presentation, the PhageEU presentation. It's a one common presentation. The last one. Yeah.
Well,
Indeed.
I can already start. Thank you, Margareta, for the introduction. I assume that most people in the audience might not be molecular biologists by training, and so it is my task today to give you a crash course into bacteriophage biology. What is a bacteriophage? Next slide, please. One more.
Just 1 second, sorry, because I need to share it so that everybody can actually see it.
Okay.
Yes, now we can see them too. Thank you very much.
Okay, perfect.
Okay. One more, please. So a bacteriophage is something very, very small. You can't see them by the naked eye. You can't see them in the light microscope. Only in the electron microscope, these structures become visible. And on this picture, it looks a little bit like a lunar lander with a capsule that sits on a landing device. Next slide, please. Bacteriophage is nothing but a protein structure that carries a little bit of genetic information. And in this form, a bacteriophage is not a living being. Biology defines a living being as something that can react to external stimuli, has its own metabolism, and is able to propagate. And the bacteriophage does not have a metabolism. So it doesn't see anything, it doesn't smell anything, it does not actively move around, it just passively, by Brownian motion, moves through a liquid. So in principle, linguistically, every action I describe of a bacteriophage, I would have to formulate passive. That's a bit too boring, so I'm not going to do that today. So a bacteriophage comes to life when it encounters its host, and that's a bacterial cell. Next slide, please. When that interaction happens, the bacteriophage can attach on the surface of the bacterial cell. That's like a lock-key situation. It finds the proper bacterial cell, and then it will inject its genetic information into the bacterial cell. And now the bacterium is reprogrammed. A bacterium normally has a program: out of one cell make two, out of two make four, out of four make 8. That gives exponential growth, we know from bacteria. And the bacteriophage, or rather the genetic information of the bacteriophage, stop that, rather use all the energy within the bacterial cell to make new phage particles. And these phage particles will then accumulate within the bacterium, and eventually they will feel confined. Next slide, please. And they will, from the inside, start to destroy the bacterial cell wall until this cell wall can no longer withstand the internal pressure. And so the bacterial cell will burst open and release the proteinophages into the environment. And they literally have nothing else in their head than to repeat this process. And now you really can ask the question, why do we still have bacteria on Earth? Why were they not all of them already eaten by bacteriophages? Next slide, please. If we look into nature, we find it wouldn't really make sense for the bacteriophages to eradicate their host. That would be the end of them as well. Actually, they just live together in a natural equilibrium. If, for example, we look into the sea water, every milliliter contains about 1 million bacteria and about 10 million bacteriophages. And now this equilibrium is not static, nothing happens, but it's very dynamic. And the driving force is the living entity, is the bacterium. The bacteria will grow up, and then the phages will start to prey on the bacteria, so the bacterial count will go down. Then the bacteriophages will not find any more prey, so their number will go down, up and down, up and down. And this natural equilibrium is really very important for nature because it keeps the nutrient cycles going. So the bacteriophages dissolve the bacteria, all the nutrients that the bacteria accumulated will be released and can then be used by other bacteria or by higher organisms. And so the question is, how many milliliters of seawater do we have on Earth? Let's quickly do some mental arithmetics. Radius of the Earth, 6,370 kilometers squared times 4 times pi. Then we have the surface of the Earth, 70% of that covered by oceans, multiplied by average ocean depth, 3.5 kilometers. We have cubic kilometers, and we convert that into cubic centimeters. So you realize that will be a relatively large number. And we do find the bacteriophages not only in the sea, but wherever we look in the soil, in fresh water, wherever we look and find bacteria, we also find bacteriophages. So next slide, please. When we calculate that a little bit, we come to 10 to the 31 bacteriophages on Earth, about 10 to the 29 bacteria, and then usually 10 to the 9 humans. Now, for us, that is really a security argument. We are largely outnumbered by them. And how do we react to them? Well, first, we don't see them, and second, we simply ignore them, because bacteriophages are specific for the bacteria, and with eukaryotic cells, human cells, they simply cannot do anything, so they're harmless for us. And not only the sheer number is impressive, but also the diversity of bacteriophages we find. Because bacteriophages are very, very specific, so a bacteriophage that acts against Salmonella will act against Salmonella and not against Pseudomonas or Listeria. A bacteriophage against Staphylococcus will act against Staphylococcus and not against Bacillus or E. coli. And so this huge diversity can be sometimes a little daunting for the researchers because they have to isolate out of this plentiful the right bacteriophage for the right application. And I have a second security argument. Next slide, please. If we look inside of us, every one of us in its digestive tract carries about 10 to the 15 bacteriophages and about 10 to the 14 bacteria. And you can really ask what they do there. Well, they simply help us digest. And more we learn about that, it becomes very clear that the bacteriophages within us are very important for human health. And with every milliliter of drinking water we take up, with every gram of food, we take up about 1 million bacteriophage-like structures. What do they do to us? Nothing. They maybe add a little bit to what we already carry inside. But now the big question is, if we have a natural equilibrium in the sea, in the water, and a natural equilibrium within us, how do we really want to use bacteriophages to actually fight pathogenic bacteria? because very obviously this natural equilibrium doesn't prevent a bacterium from being pathogenic. And I would like to show that in a lab experiment. Next slide, please. If we take a test tube with a nutrient solution where bacteria like to grow, we seed that solution with 10 bacterial cells and put the tube in our incubator and leave it there overnight. Then the bacteria love it in that environment. They start to grow exponentially. And after overnight incubation, we have about 5 billion bacterial cells. They will not grow higher in our test tube because they will have used up all the nutrients. If we now repeat this experiment and we add to the 10 bacterial cells 1 million bacteriophages specific to those cells, then the outcome is very, very different. After overnight incubation, we have a sterile tube, meaning that bacteriophages found those cells, multiplied within them, sliced them open, they're dead. Now you can well argue, okay, unfair, 1 million against 10. What happens if we even out the odds? Next slide, please. If we start with 100, we still get 0. Next slide. If we start with 1,000, that works as well. And next slide, please. If we start with 10,000, it still works. But at one point, that no longer works. Next slide, please. And in this experiment, this is about 50,000 bacterial cells. If we mix that with 1 million bacteriophages, we do not get 5 times 10 to the 9 like in the control, but we get about 1 million bacterial cells. And if we measure there, we find there approximately 10 million bacteriophages. And so in the test tube, we kind of recreate the natural equilibrium that we find in nature. And now you can ask, if you want to fight pathogenic bacteria, if you want to get rid of an infection, it might be not sufficient to simply recreate the natural equilibrium. So we would have to start earlier, like a preventive measure, where the cell count or the bacterial count is still low, and with an artificially high bacteriophage concentration, we manage to either reduce or eradicate the bacterial cells. Or we can think we add another component into this equation. For example, if we have the human immune system that also actively works, then a reduction from 10 to the 5 times 10 to the 9 in the control to 1 times 10 to the 6, plus the immune system might actually already be sufficient to reduce the infective pressure or let the body cope with the infection. Or we can also think about synergy, like we combine an antibiotic and a bacteriophage, and the antibiotic would reduce a lot of the bacteria or eliminate them, and the bacteriophages will clean up the rest. So there are many options how we actually could use bacteriophages to fight pathogenic bacteria. And do I have a few moments?
Yes. 2 last minutes.
Next slide, please. I just would like to bring you one
Next
example. Staphylococcus aureus, we heard already that it's one of the pathogens that really makes problems in our medical systems right now. It's on the WHO priority list. It's the S in escape, so nosocomial infections. MRSA is kind of a synonym of an antibiotic resistance bacterium. Staphylococcus is a zoonotic germ, meaning it's transferred from animals to humans and also from humans back to animals. So we know if we select antibiotic resistant strain of Staphylococcus in the cowshed, we will get this into the hospital, or vice versa. If we select something in the hospital, we eventually also have it in the cowshed. Now, in the cowshed, so in the veterinary medicine, Staphylococcus is known to cause bovine mastitis. This is a really serious problem in dairy farming, very cost intensive, and is the major reason why so many antibiotics are used in the cowshed. Next slide, please. We now developed a bacteriophage product that could fight Staphylococcus aureus in the animal shed, so in the cow. And this graph is a bit complicated maybe. This shows the immune status of a cow. As long as the immune status is low, it means the cow is healthy. And then this cow got infected by Staphylococcus aureus. And this cell count simply shoots through the roof. And the moment that happened, the farmer notices this cow has a mastitis, so it started to treat it with an antibiotic. But in this case, the antibiotic did not work. So the bacterium was already antibiotic resistant. And so at the peak of this infection, more or less, we said we treated it with bacteriophages, and we managed to cure this cow. This inflammation status, this cell count dropped to levels that is normal, healthy, and stayed there. And next slide, please. So in principle, we now have a product where we could cure a cow from having bovine mastitis that also works when the bacterium is already antibiotic resistant. As a consequence, we could really reduce the amount of antibiotics that has to be used in the animal shed. And in the whole concept of One Health, this would also lead to less selective pressure for more antibiotic resistances to occur. And in our eyes, such a product should really be on high demand. Everybody should be very that such a product will come on the market. But today, and that is basically the reason why we are here, under the current regulatory framework, such a product will not appear on the European market. And we hope that we will find open ears here to discuss this. Why is this? Where is the block here? And that maybe jointly we could move forward. Thank you very much for your attention. And I give on to Professor Dustig.
Yes, thank you. Thank you, Hans-Jörg. Please, Professor Dustig.
Okay, so let me continue the story about bacteriophages. Please, next slide. Maybe it's not obvious. We want to focus on practical application of bacteriophages and show their potential. But I am stepping back to the history of bacteriophage therapy and its discovery, but not without a good reason. So at the very beginning, the discovery created a lot of, I would say, stress and uncertainty, and also conflict in the scientific community. And the history of bacteriophages is really strange and turbulent from that point of view. So Félix de Herelle, unpaid assistant in Paris in Pasteur Institute, observed the plaques on bacterial loam. These are holes on the layer of bacteria grown on the plate. Now, 2 years before, not knowing by de Herelle, Frederick Twort in England made the same observation. About the same time, Gilles Bourdet, here working in Brussels in Pasteur Institute, discovered that there are antibodies produced by humans who can destroy bacteria, and received a Nobel Prize for that later. And right away, Félix de Herelle started to create the hypothesis or promote hypothesis that this hole in the loam, these plaques, are results of small microorganisms who are infecting or parasiting on bacteria and destroying them. It was his idea, and he was sure that it could be used and started to use it clinically in animal and human. About the same time, he wrote about Bourdet theory and didn't like it. And he was rather ill-tempered, so being very open about it, it created a big personal clash. And then Frederick Twort has been convinced also by Bourdet that he was a discoverer, and de Herelle discovered later, so it's all wrong. So next shows the long scientific, let's say, next slide, shows the long scientific debate, call it, where on one side, they were like Bourdet and then Northrop in US, who were sure that bacteriophages is simply a protein, kind of enzyme. And de Herelle and his followers, like Georgie Eilave, who was visiting Paris, who are sure those are microorganisms who amplify and kill bacteria. And that really was very prominent in the literature, in the discussion, that the dispute has been settled down by Ruska, who designed electron microscope. And the picture of bacteriophage, published in 1940, settled down this, seeing is believing. Now we know those are bacteriophages. However, next slide, please. In the process, there was a lot of I would say, even derogatory statement about bacteriophage therapy, so that generally the atmosphere was very worse and worse. The commercialization didn't work, and Teheran moved to United States, Yale University, but then, because of the stream of the very negative publicity, including the publication in editorials in famous medical journals telling that bacteriophage therapy is really nothing, he answered positively to the invitation by George Ilava, who already established institute in Georgia, in Tbilisi. That was already Soviet Georgia. So Bolsheviks invited the new technology coming, the Herele moved there. And next slide. And Ilava been executed by secret police in 1937, the Herald returned to Paris. The whole idea of using bacteriophage therapy became very, how to say, not in New York, not in London, not in Paris, perhaps in some obscure places like Tbilisi, maybe Warsaw, maybe Prague, but not here. Here, we don't want it. This is like a commie therapy, un-American, unproven, and so on. And I'm presenting this short science history lecture to make a point that this perception of bacteriophage application and bacteriophage therapy is haunting us till now in every discussion. So next slide. But as you know, there is AMR, and this is like a game changer. So the same journal that published stream of derogatory editorials about bacteriophage therapy, in 2017 reversed the position and published that might be quite useful in the context of AMR. And now you have really increasing the number of citation, publication, and patent application, and around 50 biotechnological companies over the world who are working on practical application of bacteriophages in different fields. Next slide. Okay, I will not elaborate on that. That's been introduced. We have AMR crisis. I just want to say that such a global crisis usually have specific mechanisms that are important. And in my perception, the main mechanism here is environmental, because bacteria are not learning. They've been selected by the exposure to antibiotics somewhere. So next slide. And this is already recognized. And one of the problems we are facing is that in farming, in animal farming, you on one hand, you have to control pathogenic bacteria because the disease is already epidemics. Because you have a flock, you have a population of animals, so it's more like a public health issue. So right away, and this, of course, is disastrous to the economics of farm. So there is use of different tools, including antimicrobials and including antibiotics. Now, when you are using massively antibiotics, and there are reports saying that in terms of tons, that this is more than human medicine, then of course you are creating an issue of sort of environmental exposure of or emission of antibiotic resistance bacteria and antibiotics itself. So next slide. So typical problem. Let's say poultry as an example. In poultry, you are using antibiotics. You are using fluoroquinones, for example. If you give the fluoroquinones, you are not giving to one bird, you are giving to 30,000 birds. So in the feces, you will track down the presence of antibiotics, and the usage of antibiotics can be fully legitimate. It's not about that. And you are also exposing bacteria to antibiotics, so they are already AR bacteria, so you are sort of giving them the chance to populate better, to amplify, and then you will detect antibiotic resistance bacteria and antibiotic that is going to manure. Next slide. Okay. Sorry. And of course, as it's on this slide, this creates a risk because you have antibiotic resistance bacteria and antibiotics in the soil. So some of those, like fluoroquinones, for example, are very persistent. Better than 100 days after you will experimentally detect this. So it can be even picked up by plant. Also, the antibiotic resistance bacteria can contaminate the plant material. So you can be theoretically vegetarian, but still may have the exposure to it. So next slide. And one of the potential application of bacteriophages is to use this in the poultry operation rather than using antibiotics. So in such situation, you are not having a problem with populating, with having antibiotic resistance bacteria, or you decrease the risk. You decrease the risk of antibiotic in manure. And using manure is a good for sort of circular bioeconomy. So you want to use it in agriculture, yes? But you have to somehow mitigate the risk. So next slide. This is particular product. It's not because frequently the bacteriophages are perceived as sort of a science fiction. Actually, this is particular product. Can be used in poultry. It's liquid feed additives. It's giving to drinking water. It is targeting salmonella. Salmonella is an environmental bacteria. It's circulated. Poultry is pretty much exposed to it. So then it goes to manure. Some salmonella are antibiotic resistant. So when you have this product, we are talking about something that is commercially available. We are already selling at, let's say, we sold for 55 million birds treatment, so which represents 550 million doses, daily doses of bacteriophage product for poultry. Now, so this is something also that is under consideration in European Union, in European Commission for registration, particular product and bacteriophage product. So next slide. So, of course, this area is regulated. So to have the access to the market, you have authorization. So this work map shows where the bacteriophage as feed additives for animals are available. If you look for human product or other application, you will have slightly different world map. So here you see that there are places where already such authorization are taking place. I want to point to Brazil, because this is a big poultry producer, and they have a structure of authorization of such product very much alike or following the example of European authorization. And they already authorized 6 or 5 of such product for poultry. And now next slide. Oh, sorry. The yellow means under consideration, and Europe was here labeled European Union as yellow. Next slide, please. So here I try to present a current position of bacteriophages in the regulatory landscape of European Union. So you have, as you know, you have 2 agencies. The one is for non-drug and food safety, and the other is for a typical drug registration pathway. And there is a DG Santa in the middle as administrative body governing this process. So if you look at EFSA, the EFSA didn't prepare any guidelines for bacteriophages, but they made several statements or positions. So they there is acceptance that bacteriophages can be recognized as a component of feed additives. There is one document of EFSA about mitigation of AMR when they are referring to bacteriophages as potential tool for mitigating AMR in a process that I just show on the slide by controlling the emission of bacteria to the environment. And then EMA on the other side already provided the guidelines for registering a veterinary drug, and there is a document under consultation for registration of human drug. Next slide, please. So this particular product that I pointed to, this anti-salmonella feed additive, the submission was in 2017. Then there was a lot of interaction between EFSA and the applicant, the Proton Pharmaceuticals. And all this was related to fitting the bacteriophages into the framework expected regarding the safety and other elements of regulatory dossier. In 2021, in March, there was a first scientific opinion. It was very positive about the safety of the product. At the same moment, it sort of was inconclusive, or saying we have no idea if it could be effective or not. And then we added additional information and data. So in 2023, there was a second scientific opinion by EFSA. It was sort of positive because there was a statement about the potential to reduce the number of salmonella, the emission of salmonella. But there was the particular issue of the coverage of our host range, meaning the question is, okay, but perhaps this is a product just for one strain of salmonella. Bacteriophages are very, very specific. Okay, fine. So we have been asked to provide the additional data, and it was now focused on host range. So we provided this data. I know that we did a lot of work and studies and provided quite complementary evidences. And EFSA approved the third opinion that is focusing on this aspect. And the document is still not unofficial, so I will not make the comments about it. Rather than we provided a strong support. And next slide. Here we are in the process, correct? So the scientific part of the registration at this moment is done. In my opinion, this will be going to the next stage. The next stage is political. This is Standing Committee on Plants, Animal Food and Feed, SCOPAF, where you have even voting formally to approve the decision. So that this body is receiving the opinion made by the agency and can make the decision. So next slide. So this for me is interesting. I don't know. Well, we should follow. That's the quite advanced stage of registration, meaning that we will see if the application of bacteriophages is still sort of mirage, like it used to be in the past, maybe somewhere in the future, or something real that can be applicable and you know, and can be helpful in solving certain problems. Thank you very much for your attention.
Thank you very much, Professor Dastik. A lot of food for thought. And now I will hand over to Frank, who I see brought some bacteriophages from Slovenia.
Yeah. That's what we all do, like getting the page in the vials.
Perfect,
So,
please, Frank.
Good day also from my side. We had nice presentation about the animal health and also then food safety. I will focus more on the human therapeutics. And my sincere thanks also to all of you just because that means that you are here, just not mean that you care about today, about tomorrow. It's for the AMR issue. So please, next slide. So I know that all of you are probably aware of these facts, but I think they are still important to see them, and especially for the Europe, that according to 2022, there were like 33,000 deaths annually because of AMR issues. And these are only direct deaths because of the antibiotic resistance. Then we have additional issues with increased mortality rate, worsening outcomes, and economical burden. What awaits us, and what Mr. Wölken also nicely said, that in 2025, there's going to be 50 to 70,000 deaths because of AMR just in Europe, and for the whole world is going to be expected to be 10 million if we are not acting and we are living as is. So if we are going with the current pace, definitely the perfect storms awaits us. We don't act, and they're like maybe because of that. They were already mentioned partially, and the first one is efficiency of antibiotics is decreasing. The left graph is just an example. I know that's small text, but how many antibiotics are doesn't work anymore for specific bacteria, and there are just few of them here, so there are plenty of them more. The right side, there are less and less number of new antibiotics in development or also registered. The blue bars, just visually, you can see like for different time periods how many new antibiotics have been registered. We are going down with these numbers. And then just an example, for the cancer drugs is the orange the tabs bars, which is great for the cancer treatment, but still the issues are on the both sides. So obviously we have two issues, and I think that investment in alternative to antibiotics are needed, and because of low number of investment, we need some kind of push or support from the government institution, from the EU side. Next slide. And if I now focus only on bacteriophages as the solution to solve this one, and as nicely said already, it's nice example of One Health. So with phages we can start from food safety to the animal health to the human therapeutics. Just as a current status in the human treatments, where we are with phage products, separating maybe in the two fields. First one is development of phages as a conventional drugs, as a human medicinal products. This one, all over the world, the current clinical trials are that the companies or the groups or the institutes are in the phase 1, phase 2. And for 2025, it's planned that first phase 3 study is planning to happen in the US. In EU, companies are doing clinical trials, and I have to also say from the EU perspective that also EU is world's biggest GMP producer. From the personalized approach, which is also called compassionate use to magistral products, there has been hundreds of successful treatments all over the world, which is great. That obviously the technology definitely works. And EU hospitals, again, looking from our perspective, have done a lot of treatments, and also being in Belgium also one of the pioneers in the magistral products. So why I'm saying all this, we have been, Professor Dajtic nicely said that the long history of the phage therapy. I can also say in the last 10, 20 years, EU, as a EU companies, industries, or academic, we have been in the front row for driving the phage technology. And I hope that it won't happen the same with AI or some other technology where EU lost the track because of different stuff. So that's why we are here to try to look which challenges do we have to address in order to keep up and be the world leader, or one of the world leaders also with the phage technology treatment. Next slide. So what are the immediate challenges? I separated two biggest one. One is, which were also slightly addressed. So one is the regulatory, and one is financial incentives or support. Next slide. So from the regulatory perspective, again, for the phages to be used as conventional drugs or for broader use as application, the guidelines veterinary therapeutics is being currently to be put into place in the review procedure, and also for the phages personalized treatment. EDUCAM, EMEA, in the last year, it has put this guidelines in place. So I have to say that things after all these years are moving, which is nice to see, great to see. We would just like to express that we go with the same fast pace also forward in order to enable the drugs or the solution also to patients as soon as possible. Next slide. Then the second immediate challenge, our financial incentive support, as also already nicely presented by Mr. Wölken. It's the antibiotic, or not antibiotic, but just treating this kind of treatments is, from the financial incentive, it's quite challenging. So from the financial incentive for support, first thing it's important that we address is have more incentives of development stages. So supporting research stages, just general phage therapy research stages. The second one is supporting the clinical trials, because at the end of the day, we know that the phages are work, but of course, to have the proper drug on the market, there needs to be the clinical trials in order to understand what is the dosage regime, how long the treatment has to be done, and all this stuff. Second one is then establishing sustainable reimbursement policies for new conventional drugs, so that at the moment, anything that comes as let's say antimicrobials at the market, it's as a last resort, which is really difficult then for the industry, for somebody to have financial viable case. So if we, with different models, if we help this kind of stuff, it will be also more investment into the field than what we saw, the blue bars, it will change and we'll have better solution. This is for conventional drugs. And the second one is to establish also the reimbursement for the person. There has been a lot of time cases where antibiotics didn't work anymore, and phages could save life, could change life, but there's need to be some kind of personalized approach, financial reimbursement, in order to help EU citizens. Next slide. And speaking of that, it's always better to show real case. Sadly, it was not the best case, but with as good as possible outcome. As said, there has been hundreds of cases where phages did save life. And what better to speak of, it was a patient, actually the case that happened in Brussels, a few kilometers away. So in 2016, 22nd of March, there was a terrorist attack in the Brussels airport. There have been 32 dead people and hundreds of injured. And one of the injured person was also this patient. She was 30 years old at that time. So she's been, she had 60 surgeries. She's then been for 3 years in the hospitals just because nothing worked. And she got an infection of Klebsiella, and then all the antibiotics treatment didn't work. The spleen stopped working. And what saved it at the end, to get out of the hospital and to start living again, it was the phage treatment that actually also was prepared in the phage in the Belgium. So what I'm trying to say is that we all have this in mind, that we have the solution for the different fields. And now, yeah, we have to figure out the regulatory and also economic perspective. Next slide. So yeah, this is all from my side. Look forward for the discussions.
Thank you. Thank you very much. And thank you for sticking to the time, because we are really perfectly on time. And thank you, Frank, for finishing. I think with this strong message, all of us, we remember those events at the Zaventem airport. So it's good to know that also phages played their role in helping the victims. So now, after this detailed introduction from the phage community, I'm happy to hand over to regulators. The European Commission has been mentioned several times, European Medicines Agency, European Food Safety Authority. So we will start with Mr. Cornelius Schmalz, representing the Intelligence Gathering, Analysis and Innovation Unit at the Health Emergency Preparedness and Response Authority, HERA, DG HERA from the European Commission. So please, Cornelius, the floor is yours, and this is your presentation.
Thank you very much, Margareta. It's a pleasure to be here. Thank you for this very interesting and fascinating meeting, for the great presentations that I've already heard this morning. I'm here not primarily as the regulatory arm of the Commission, but more as the funding side. That's what I'm going to give an update here. If we can have the next slide directly, it's just 5 slides. So this is the brief introduction of HERA to those who don't know it, since we are still a relatively new kid on the block, either as a toddler or as in puberty, considering whether you consider us as a human or as a cat or as a dog. We were created in September 2021. We have a budget since this was already in the middle of the MFF, from existing programs. So we use Horizon Europe and EU for Health mostly, and RescEU a little bit. Our mission is to strengthen Europe's ability to prevent, detect, and rapidly respond to cross-border health emergencies by ensuring the availability and access to key medical countermeasures by looking at the entire value chain. The key word here is really medical countermeasures. This is the domain of HERA, and we try to do this, as said there, from the whole value chain, really from the analysis of where are the gaps, the research and innovation value chain, to then development, production, procurement. There's another unit in our DG that deals with joint procurement of member states, so helping member states to procure medical countermeasures, and all the way to distribution and stockpiling. This is where we work with the RescEU program. Next slide. These are our 3 priority areas. So we deal with pathogens with high pandemic potential. That's where, of course, you expect COVID, influenza, filoviruses, Marburg virus, Mpox, and these things. We deal with medical countermeasures against chemical, biological, radiological, and nuclear threats, CBRN, and we deal with medical countermeasures for threats resulting from antimicrobial resistance. And that's why we're here. That's why we have an interest in this. Next slide. What is our role on AMR? So this is our mandate specifically for antimicrobial resistance. It's, of course, to ensure the development and access to proper antimicrobial resistance medical countermeasures, including therapeutics, antibiotics, new and old, and alternatives such as phage therapy. It's about diagnostics, and it's about vaccines against priority bacteria. So you see this is countermeasures in a broad sense, of course. Next slide. What have we done already on phage therapy? We have actually done quite a lot. HERA is funding WHO for their pipeline review on antibacterial agents in clinical and preclinical development, which also covers alternatives to antibiotics like phage products. The latest review, updated in June of this year, highlighted the existence of 13 bacteriophages of phage-derived enzymes in development. Very topically, just yesterday or the day before yesterday, I think yesterday, we signed our Director General, or maybe it's 2 days ago, our Director General signed the second instrument, the second funding agreement under HERA Invest, where together with the European Investment Bank, we provide through EU for Health the de-risking for the EU to provide venture debt financing to a company that supports, which develops the product Sniper 001, a cocktail of 4 engineered phages that, via a very complicated mechanism that I managed to almost understand yesterday, with CRISPR-Cas selectively kills fluoroquinolone-resistant E. coli. And that is the even more impressive figure in terms of numbers, actually. And I'm glad that my colleague Alessandra Martini from RTD is also here. Through Horizon Europe, we have since many years actually already invested a total of over 80 million euro for 60 grants addressing bacteriophages related research. So I hope we are responsible for some of these 497 papers that were published on phages. So our funding is responsible for some of the papers that were published in 2024. Next, and I think last slide. We are also, of course, we will continue this funding for AMR, and also including phage therapy for the One Health AMR partnership, which is under construction to be established in 2025, which is a way of partnering with member states, with funders in member states, with research actors in member states to reduce the burden of AMR with an extended integrative program to better understand, prevent, and treat AMR, including supporting R&D for the development of novel antibiotics and alternatives. And we will take a holistic One Health approach, very important in this area, as highlighted by several speakers, to attain optimal health outcomes, especially taking into account the link between the health of humans, animals, and plants in our shared environment. And I think we've heard very impressive examples of that. I think that's it. Or do we have a last slide? Thank you. Voila.
Perfect. Thank you. Thank you, Cornelius, for this very efficient presentation, but a lot of information, a lot of numbers, so a lot of money spent. And as you said, also a lot of pages, yeah, covered by results of, yeah, pages on phages, indeed, phage research. I'm happy to hand over now to Aleksandra Opalska from DG SANT, from the Medicines Policy Authorization and Monitoring Unit. Please, Aleksandra, the floor is yours.
Good afternoon. Also from my side, unfortunately, my voice is not very good, but I hope you too. Not need antibiotics or bacteriophages in the very soon future. I'm here today with my colleague Peter. I the English version of your name. And we would like to present you DG SANT perspective and activities that we have on AMR. So if we go on for the first slide, thank you. I would like to draw your attention to this photo. I often start my presentation with this photo because I think it is very important to remind ourselves when in 1932, kids with tuberculosis, they were treated with the only possible way, which was sunshine and rest. At that time, and we heard the history of bacteriophages, the bacteriophages were already under radar of scientists. But now we are facing what we are facing. We are facing multi-drug resistant tuberculosis. And again, we hope that bacteriophages can also help in this field. Now, if you go to the next slide, please. I will quickly address challenges and activities that we have. And we at the Commission, we thought about the toolbox. So together with colleagues from DG HERA, but also from DG RTV, DG ENVI, we thought that we need a toolbox in order to tackle the public health threat, which is AMR. And we have already heard different and several activities that DG HERA has. I will focus on two initiatives that were launched in 2023. If we can go back to the slide, previous slide, no problem. So the first one is about, we launched the proposal for a council recommendation on AMR, and there we have so many actions on AMR, including the prevention, including specific targets on consumption across EU, and also some actions at global level.
Excuse me, Aleksandra.
I'm going to close the slide and open it again because they can.
We have an issue with the slides. They are not changing, so our colleagues joining remotely cannot see the slides. And I was also told that on the web streaming, because the meeting is web streamed, also slides are not changing. I don't know why. I hope previous presentations were working well.
No complaints on the previous one.
Yeah, indeed.
Just close and open again. Sorry.
I can also go ahead without presentation if you prefer.
Yes, I mean, if Aleksandra agrees, we can then later share also the slides, yeah, with the participants. But let's try once again.
Can online confirm maybe if it's.
Yeah, it's working. Perfect. Thank you. It's working.
Then I was.
I usually do policies, so sorry.
No problem. So now coming back to the second initiatives, I would like to focus is the revision of the pharmaceutical legislation. As some of you are aware, this is a major revision that we are doing, and it tackles different challenges within pharmaceutical fields, so such as access to medicines, affordability, but also very important pillar, it is AMR. So the Commission proposed two main pillars with regards to AMR. First one is about prudent use. We know, all know that inappropriate use of antimicrobials is the main driver of AMR. Therefore, we thought that this is a really key element that must be tackled. And within the revision, we proposed several provisions. For example, prescription status for all antimicrobials across EU, Then we propose also specific information for healthcare professionals and patients to raise the awareness, because I need to tell you that the recent survey that Commission did on awareness gave a really bad result, because 40% of EU citizens, they still think that antibiotics work against viral infections. So as you can see, this is a very important element of tackling AMR. We also had a specific measure with regards to the package size. I can bet that each one of us has some member of the family of friends who told you, well, I have leftovers of the previous treatment, so I will reuse it because I have a sore throat or any other medical thing that, in my opinion, it is good to take. So we really need to fight those kind of inappropriate uses of antimicrobials, and that's why several provisions are included. Then the second main pillar of our revision, it is battery incentives. And we heard the magic word of incentives several times today. And that's why the Commission proposes really tangible proposal, innovative one, because we have to admit that none of other jurisdictions, they have the courage to propose such a innovative incentives, which is the voucher, exclusivity data protection voucher. It is a very powerful incentive that after our assessment, we figured out that this is a way to boost development of new antimicrobials. In particular, we hope for new antibiotics. We have very strict criteria because, as I said, it is a very powerful reward, but we consider that we acknowledge that the business model doesn't work, the standard business model doesn't work for antimicrobials. And then if we go to the next slide, please, I would like to also draw your attention to the provision that we included in the directive proposal, Article 20A, which gives us possibility, because we heard that there are some problems with regards to the authorization at EU level. Of course, bacteriophages are used under compassionate use at national level in several countries, as it was mentioned, in Belgium, in Poland, Georgia, and probably also other countries. But the Commission would like to propose something that will adapt the future technologies that may come. And those are really for innovative products that, for example, bacteriophages it would apply. And we put even this as an example in the Annex 7 of our proposal. I think I reached the limit of 5 minutes that I was given, so I will thank you for your attention and happy to answer any questions you have to us. Thank you.
Perfect. Thank you, Alexandra. So we will be now moving to our online participants. So technical check. We'll see if we can hear them. And we will start with Dr. Radu Botgros from the Public Health Threat Team at the European Medicines Agency.
Hello, I hope you can see and hear me.
Can hear you, and
I'm
the
just
presentation to be sure.
Put the slide on, so let me know if you see them.
We can see your desktop. No, not your, yeah, but we don't see the presentation.
Okay, that's not great. Let me try again. If not, let me see. Maybe now.
Yes, we can see it. Perfect.
Very good. Excellent. So thank you very much for inviting me and thanks for the great presentations that we have heard. I'm very happy that, the introduction has been made, that a lot of perspective has been given on phages. I will try to concentrate on just a few messages that I think we need to convey, also because the time is relatively limited. So let me just go and tell you a little bit on what we consider are currently the scientific and regulatory issues that preclude an approval of a putative new medicine containing phages as at present. The first important one is something that has been mentioned but is pivotal, namely that we do not have data generated in well-designed randomized clinical trials that currently have shown efficacy of phages in any indication proposed. I think this is something that we need to keep in our minds. It has been mentioned before. It needs indeed financing, and we need, as a scientific society, to come together to have these studies, or the study, the proof of concept study run properly, so that we understand it, or maybe we confirm that these products work. At present, there are many small studies that have been conducted, and I have to state the fact that these studies are not interpretable from the regulatory perspective in view of a potential approval. And I have attended very recently a relatively big conference organized by the Learned Society of the European Union, by the European Society of Clinical Microbiology and Infectious Diseases, and its group on non-traditional therapies that obviously include phages, which took place a few weeks ago in Lyon. And also there, it became clear to me that this is one of the main things that I think we need to work together on. We need to join forces to have the proof of concept generated, rather than conducting very small studies here and there showing apparent efficacy, which unfortunately cannot be used by regulators to approve a product. I agree that with what has been said, that phages are generally considered safe, despite I have to state that potential spread of resistant genes between bacterial species cannot be excluded and should probably be investigated. But in general, they are safe, but obviously any potential product containing phages needs to be GMP compliant, and also GMP, respecting the GMP standard reassures us that everything is in order, that the product is purified, it does not have rest of bacteria and all these kind of things, and that indeed its general safety is maintained. There is indeed also a potential need to fine-tune the legislative framework for personalized therapies in general, and this applies to phages as well, as Alexandra has just told us. And it's good that the European Commission, through this revision of the pharma legislation, is considering this. So I have to tell you that phage therapy products are investigational biologicals in the European Union, and the engineered phages are also advanced therapy medicinal products, and these are all subject to the pharma legislation and need to be GMP manufactured. You heard that we have at the EMA developed 2 guidances. They are available on screen as well here with their respective links that you can have a look at. And importantly, this expanded access / compassionate use that is being used in some countries of the European Union and some other European countries that are not part of the European Union. This has indeed numerous examples, and it is good that such a compassionate use exists, and that these kind of products can be given to patients that have no other treatment options left. That said, it's not a route to regulatory approval. So we need well-designed randomized controlled clinical trials as a prerequisite so that we are able to delineate the benefit risk in any specific indication. These two these 2 points are actually complementary and not fighting each other, but we need really to understand, because obviously if phages work, as we all hope they do, they can and should be given to a wider population and not to just patients that have limited treatment options potentially. So indeed, more work needs to be done on this. And on my last slide, you see here that as has already been presented partly, can you still hear me?
Yes.
Yeah. So we have two kinds of potential drugs containing phages. One is predefined, so to say, cocktails. Things where the strains of phages are being selected based on statistical, let's say, considerations, as working on a high number of bacteria from different species. And here, the legislation, the provisions of the legislation, we believe are adequate to approve such products if indeed the data from the trials show that they work and that they are of good quality. And so here we have options, and also depending on the, because once you start using those products, there may be a need to vary the composition, and here we can have a separate marketing authorization or even a substantial extension procedure that we can use in these cases. And the second part, the personalized therapy, where the cocktail of phages is selected based on a phagogram, is definitely a product where the composition is variable, essentially. And here, indeed, as the current legislation is being drafted, this may need some further tweaks, and you heard that in the current legislative proposals, this is something that is being looked into, as indeed licenses the active substances, meaning the phage strains, at present is not possible. So I think all in all, we are working together on this, and this is another thing that I wanted to stress. We would like at the EMA to see more and more of the developers coming for scientific advice. So we have a procedure in which we are eager to talk to developers. Unfortunately, we don't see all that many products, despite, as you have seen, the veterinary guideline is in place since 2023, so more than a year ago has been put out. And we are working on the human side, but we don't yet see that many applications. So we cordially invite you to come to talk to us so that indeed we can move fast. Or at least as fast as we can. I will stop here in the interest of time, and happy to answer questions. Thank you.
Perfect. Thank you very much, Dr. Botgros, for your presentation and for your openness to work together. I think that's very much appreciated. And now, last but not least, we will move to our colleagues from European Food Safety Authority. We will hear from Mr. Ernesto Liebana Criado, Head of Biological Hazards and Animal Health and Welfare Team at the European Food Safety Authority, and his colleague, Mrs. Rosella Brozzi, who is a scientific officer at EFSA. So please, the floor is yours.
Hello, good afternoon. I hope you can hear us well.
We can hear you, yeah.
Perfect. I will share our screen from here.
Yes.
If you don't mind. Okay.
Yes, we can see it.
Okay, perfect. So we'll be fast because we know that we are pressed for time, but we have a number of topics to cover. So we'll basically address how bacteriophages have been looked at in different EFSA risk assessments. And since the title of the meeting here was very much about how to combat antimicrobial resistance using phages, I want to go back to an old opinion from 2016 already that we developed together with our colleagues in the EMA and with the colleagues working on veterinary medicinal products. And this opinion was really, or is now for us, kind of the Bible on potential solutions to reduce the need to use antimicrobials in animals. And to cut a very long story short, we came back to three pillars: reducing, replacing, and rethinking. And within this one in the middle, replacing, we had a look already at the time many alternatives that can be used instead of antimicrobials. These are things from vaccination, immunomodulators, food additives, feed additives, and within those, bacteriophages. So I will not dwell on a lot of these things that have already been said. However, it's important to highlight that bacteriophages, or most of them, are highly specific and they have these narrow host range. And that creates a bit of a problem for some of the applications that we looked at. Already at the time, when reviewing all the literature, it was clear that they may have phages a positive impact on certain animal health parameters, and there were already papers out there showing that they can reduce enteric colonization and shedding for some zoonotic pathogens, such as Salmonella, Campylobacter, and Listeria. A lot of these things, of course, are not animal health problems, they are human health problems, and therefore, by intervening in food production animals, we could perhaps prevent this type of zoonosis. This slide lists a number of specific cases for particular animal diseases, also like diarrhea, mortality in chickens, and also in some aquaculture species. However, a major limitation of using them was that the target bacteria may develop resistance. And we concluded that also the problems of the unclarity in regulatory aspects is a blocker for innovation in this respect. These examples, you can consult them there, but I will not go through them because they are also outdated, but it shows some of the conditions in animals where at the time phages were successfully used. As a result also of this joint opinion with EMA, the colleague from EMA has shown that there are two guidelines from the CVMP, the Committee on Veterinary Medicinal Products, from 2022 and 2023 that give already some indications of what could be used for applicants, future applicants to develop such products. So this is one aspect of bacteriophages. The second one, where we have been working in EFSA on the use of phages, is as surface decontamination agents. As you know, in the EU, we are very restrictive in anything that is used to decontaminate food. In fact, very few things apart from lactic acid and hot water are allowed, because we believe that prevention is better than cure. But back in 2016, we got an application for a product called Listex at the time, and this is a cocktail of phages that is applied to the ready-to-eat foods to get rid of Listeria. The assessment was done, and although generally speaking, the efficacy and safety of the product were thought to be good, there were some uncertainties, and then the European Commission decided not to proceed with the approval. Very recently, we have, due to new data that has been generated by the same developers, we have received in August a new dossier for this Listex. Now it changed name, it's called PhageGuard. And the dossier was considered valid very recently this week. So the clock starts ticking for us to produce a second opinion on this particular product. And now I will pass the floor to my colleague that will explain about the food additive part.
Okay, good afternoon from my side as well. My name is Rosella Brozzi, and in fact, I'm a scientific officer of the FeedCo unit, supporting the FIDA panel in the assessment of feed additives. And I just wanted to present your experience in assessing one application of phages in the area of feed additives. This is just to brief you, introduce you the legal framework. There is one legislation dedicated to the marketing of products using animal nutrition as feed additives. This is complemented by another legislation detailing the data requirements for applicants to submit the technical dossiers. And these legislation are somehow also complemented by some guidance documents produced by EFSA to support applicants in the preparation and submission of the applications. This from the administrative point of view, but also the scientific point of view. And this is just to really give you the framework on the feed additives. Feed additives, according to our legislation, are those products, including microorganisms, which are added to feed or water to exert one of the functions that you see here. So not any function, but they are defined by legislation. And in the example I will give you today, we are talking about the intended effect of fiber will affect the animal production, performance, or welfare. This slide is just to highlight one point which is important in this discussion, which is from the purely regulatory point of view, bacteriophages under the framework of feed additives cannot be used and cannot be seen as an alternative to antimicrobials, because we are in different legislative frameworks, and the main difference is that the scope of the two are totally different. We saw that veterinary, and we know that veterinary medicinal products are meant to cure or prevent a disease, while we saw in the previous slide, which are the intended effects of feed additives, which are not meant to cure diseases. In fact, they have to be used, they should be used on healthy animals. They are administered via feed and water, normally during the whole life or full production stage of animals. And they are also, at least the ones intended to be effective in animals and in the environment, they are also linked to a specific formulation that is describing the legislation. In this case, feed additives are not bound by GMP provisions. This is the example of the two opinions already produced by EFSA, adopted by the FIRA panel regarding the use of a bacteriophage called cocktailers under the framework of feed additives. This is the same product that you saw before that was presented by one of the previous speakers. I will not go into the details. These two opinions are already published, so they are available online. Some of these aspects were already included. Indeed, as the speaker said, there were not guidelines available specifically for bacteriophage-based products when the application was submitted, but there were already general guidelines on the different aspects that need to be covered by the assessment, which is the description of the additive, the characterization of the additive, the safety for the target animals, consumers, users, and environment, and the efficacy. I will not go into the detail for the sake of time, but okay, as it was already said, the opinions fully address the safety of the product, which was demonstrated based on a set of data. The product is composed indeed by 4 bacteriophages intended to be replicated in Caninarum. It's to be added to feed and water. And the intended effects is the reduction of Salmonella carriage in poultry, the reduction of Salmonella load in the environment, and the improvement of the performance or technical performance of birds. The opinions were indeed fully positive for the safety, but not for the efficacy. And the main problem was indeed, as Ernesto said before, because of the narrow host range of the product, which is indeed one of the intrinsic, it's due to the intrinsic nature of the product. There is a third opinion now in the pipeline. It has been adopted recently by the FIRA panel, addressing indeed the efficacy. And I cannot disclose anything because it's under embargo, but it will be published shortly, so you will be able to see the outcome of that assessment. And just I wanted to say that indeed, as I said at the beginning of my presentation, there was no guideline specifically addressing the use of phages as feed additives, but from the experience gained by the assessment of these applications, and now we have prepared criteria for characterizing phages across EFSA applications, and these are compiled in a new guidance document that is currently under public consultation until February 2025. So you have the opportunity to provide comments, and we invite all stakeholders to go through that document and provide comments. And that's the end of our presentation. Thanks a lot.
Thank you very much for this very interesting presentation. Now, I would like to thank all the speakers, all the panelists for their interventions, because we have finished the first block and we can now move to the discussion. I would really like to give the possibility for our participants to ask questions. However, I'm happy that also we have with us in the room Mr. Andrew Kaitis, member of the European Parliament, who is also currently S&D coordinator in the SANT committee and previous health commissioner. I know that very often the time of MEPs is very restricted, so if you would like, maybe take the floor now before, no, it's fine? Okay, listening.
Listen to you because now it's a bit
Okay.
very important to know from EFSA. I remember my time.
Yes, thank you very much for your
You follow
presence.
development because it's not new topic.
Indeed, indeed.
It's good to know from your side much more.
Thank you very much for your presence. And indeed, in the very beginning, we had quite long presentation from the PhageEU, so from the Phage community. So maybe before I open the floor for any questions, I would like to give the possibility for the representatives of the Phage community maybe to react to what has been said by the European Commission, EFSA, EMA, because I think a lot of issues have been raised, some shortcomings of bacteriophages, the issue of clinical trials, that shortage of clinical trials, also maybe lack of applications for scientific opinions. So if you would like maybe react somehow to what you have heard from representatives of the European Commission and agencies, I think.
Yeah, thanks. So thanks for nice presentations. I will just add from the human therapeutic point of view that I do agree. So yeah, at the end of the day, we do need the clinical trials. Being in this field for a while, I do see that we are getting more and more slowly there. So we confirm with several clinical trials that the phages are safe, which we all agree. But also to set up the whole panel, it's just to have the platform. So from the selection to the manufacturing to the trials, and I do see that now several companies are in phase 2 clinical trials. So, and as said, it's in the US. It is true that now we're going to the phase 3, but with this one, that will also see also positive result, convincing, as you explained, convincing results. And yes, I do agree that we have to separate what you explained from what is in Lyon, what was the personalized approach, but in that commercial treatment, that definitely needs to be done. I'm quite positive from that side. I do it. It will also help, and I'm happy to hear that you're also working on the legislation. The sooner we put in, which sometimes this is a bottleneck where at the end of the day, somebody has to finance the trials with the government. If the road is, if we are understood what the requirements are, it's easier than to plan, it's easier than to do. So in this case, it'd be helpful to get the guidelines. And what was here also as a question, so whether the phage will needs to be adapted with time. First, we do need to see first efficiency trial, which will definitely get there. But it definitely would be positive that you already mentioned that one, that is a possibility. Again, that gives the assurance to the investors, to the companies going there, that's a possibility. And then that is again additional added value compared to the antibiotic stuff like that, where here the changes can be much faster. And from the regulatory point of view, and I can speak from a manufacturing point of view, that if we have the platform doing the same production, doing the same quality parameters that it was raised, that then we say, yes, the product is safe. So we don't need to go through the whole clinical trial, which is important also from the business model perspective to assure, let's say, at the end of the day, safe, but also cost-efficient drugs for the patients.
Perfect, thank you. Professor Dastil, do you want to react?
Short comment. I see based on what I've heard from regulatory agencies and from European Commission that perhaps we are reaching certain interesting transformation point in terms of bacteriophages in European Union. I hope for, because we spend a lot of time sort of like trying to understand how within existing framework this technology can be introduced into the market. And I think that this discussion is more like really how it's becoming very concrete. Especially I'm glad that sort of EFSA also start to think about bacteriophages in the microorganism using feed additives, for example, in the guidance, things like this. Each of them are small, but together they create a situation that certain understanding or predictability of somebody who wants to move on with using bacteriophage and develop a product with the vision of registering this in European Union might get some assurances that there is a risk, but also there is some perspective, yes? And before it was like bacteriophages were on the shelf. They were not on the table to be discussed, to be think seriously. So I sense that perhaps that's the moment that they became slowly like getting on the table, and I hope for it. So
Yes.
Thank you.
Now they are literally on the table, as we can see here, small bacteriophages. Hans-Jürg, do you want to react? No? Any? Okay, great. So now I would like to open the floor for any questions from participants. Please introduce yourself before asking question and tell us to whom you address your question. So please, who will be the first one? It's always difficult to find the first person. Any questions, comments, reactions? Tara, please.
When you speak about basically the reimbursement when it comes to the personalized medicine, what prices are we talking about? Like, what are the numbers? How much does a treatment with phages actually cost?
It's a good question. I'll try to be as practical as possible. In that all now at the moment. So at the moment, and also what Mr. Bodras, also Dr. Bodras said, things needs to be GMP, so it's going to be produced. And from this perspective, for me, it's like similar to personalized treatment for the gene therapy, right? For the gene therapy, you also have to produce. As if I'm not wrong, for the gene therapy, if one drug it's like several million or 2 million, we were not speaking here about the same numbers. It would be few 10,000 of euros, like 10,000 or 50, which is still too much, or too much. It's a lot, but yeah, that would be in the range. So I don't know, but my perspective it would be, because I think as a EU or the members, we try to make the drugs affordable as much as possible, so that there are like young human medicines drugs which are for the bigger population, so that everybody can afford. And then if there are cases where nothing helps, and as we saw you missed also the case from the Belgium where the lady was 3 years in the hospital, it's not only the cost, it's of the health insurance, also the life stuff like that. That in that case we have exemption, and we could also have the funding and reimbursement also for this case. So when we use all the other resources, that's also the possibility. And within the going, I think that's additional to point to where the phages have been and where it's not. So we are now different because all the technology develops that one. We're using the same technology as production of vaccine from the manufacturing point of view. And this is where the health industry goes in the personalized approach. Phages fit nicely. So we can have like general approach, but if there is a need, that we have also a solution for that. I hope I answered the question.
Any other questions or comments? Yes, please. Please introduce yourself, because we know Tara. She helped organizing everything.
Yes. So good afternoon. Also, we could say almost good evening. It's quite dark outside. My name is Pierre Sultana, and I represent Animal Health Europe. So Animal Health Europe is the association representing the producers of veterinary medicines in Brussels, right? I think antimicrobial, we can all agree that antimicrobial resistance is everyone's concern, and we really need to do something about it. And that it's perhaps the moment also to advertise a little bit that, as you're aware of, we've been asked to reduce through the Green Deal the sales of antimicrobials by antibiotics at 50% by 2030. and that by since 2011, the sales have decreased by 53%. We are not there yet because the countdown is from 2019. But this year, this has to be acknowledged as well that we are on a good way in this regard. And this is sometimes a little bit neglected. It would have been perhaps, I mean, it's important, I think, to mention it's in our discussion today. In fact, there is one thing. It's about the basically your demands. So I do understand that once again, as mentioned, everything to support the fight against antimicrobial resistance, any move is important. However, we on one hand also have vaccines, and on the other hand, we have our sectorial regulation on veterinary medicinal products from 2019. And it's just like perhaps a role here to request this regulation, this approval system is really a gold standard globally. So the Americans, the Japanese are looking at us because of this system, which ensures high efficiency, efficacy of our products. So please, I don't know if it was I had reassuring thoughts towards the end of the discussion, but please don't think about reopening our regulation or destroying the high and very safe regulatory approval system that we have for veterinary medicines. That's the only thing. Thank you.
Anybody would like to reply to this?
No. I wonder why we are going to destroy, or we propose to destroy the system.
I was wondering because I thought you were asking for when we started very early the discussion. It seemed as if you were asking for derogations or to adapt the system to the needs of phages. It's reassuring to see that you're working towards, improving within the system for the human side, and I just hope that it is also the same for phages used for veterinary.
Yeah, the existing regulations are for the certain categories that are all regulated by those regulations. Mm-hmm. So when you have any innovative drug in animal health, and you always will have, for example, the vaccines when the live viruses became vaccines, you have to solve certain particular interpretation of existing regulation to allow it happens. Yes, you have to decide, okay, what exactly it means that GMP for making bacteriophages. What does it mean, the quality assurances? Certain elements, perhaps even of clinical trials, that are not necessarily coming out as important if you are designing a trial for different. That's my position. I think bacteriophages, from that point of view, we are not asking to waive the regulation and to destroy the regulation. But for example, the regulation have the history. The antimicrobials being regulated with the vision of developing of novel antibiotics. So when you are coming with bacteriophages, yes, you have the framework, and part of this, like the points that you have to check, sometimes cannot be addressed, not because the bacteriophages are something weird, but because you cannot apply the same methods, like analytical methods, for biologicals that you are applying to antibiotics, or you cannot measure the efficacy in vitro, for example, against certain strain of bacteria using exactly the same kinetics and simply copy the book. So that's the only thing what we are proposing. We are saying we are trying to understand how to fit into the existing regulation, and it doesn't mean the opening or destroying the regulation. It means like opening the discussion about a particular chapter and extending by, you have A, B, C, D. As an example, we need E. That's my feeling, that's how how we are thinking about the regulatory landscape for bacteriophages for veterinary medicine.
Yes, and I think we also, my name is Michael Fink, I'm from PTC, also from PhageEU. We also have to consider that less and less antibiotics are available for farming, because due to the split of medical products and veterinary medical products, there's now the option to take out certain antibiotics which are used today in veterinary medicine and not available in future. And therefore, I see there coming up a big lack of antimicrobial treatment in this sector.
So I hope you feel reassured that we want to work together.
We are not antagonists.
Yes, and yeah, I'm happy to continue the dialogue also after the event. Happy to discuss together. We have still a few minutes left, so I don't know whether there are any other questions. Yes, and I would like to indeed give the floor to the Commission because the time was limited, so please.
No, I just wanted to have a little bit provocative question, just to stimulate a little bit our discussion. Because we see that efficacy is questionable, right? And then we see that when we use bacteriophages, we need to use simultaneously antibiotics. So increase, right, the consumption of antibiotics. And then the third thing I learned today about lab results, that if we have bacteria, if we come too late, then it will not work. So my question is, what is real added value of having bacteriophages? A little bit provocative, so but I would like to have scientists' view on this topic.
So who is brave enough?
Yes.
If it was shown by you when you come too late, it doesn't work. So what was the value? What is needed of phage?
But you have to find a situation where it actually does work. So you have to think when you would have to apply the phage that it would give a specific effect. If we talk, let's say, another infection in the cow, you will have to bring the bacteriophages to the spot where the infection takes place, because they will not move on their own there. So you have to bring them there. So you inject something into the other, that's a veterinary medicine. And then the question is, can you change something in its natural equilibrium? And if there's a biofilm, the cell count, so how many bacteria are there causing the infection, is not very high. So if you come with an artificially high dose of bacteriophages, you can actually achieve a reduction. And if you apply it several times, you can get an elimination.
But you also mentioned that prevention is very, I mean, the bacteriophages could work as a preventive measure. So that's why I'm also questioning
that is a treatment. That is a treatment, not a preventive measure. If we consider the application against salmonella in chicken, where we would feed the apply the bacteriophages to the drinking water, then the idea is the phages are already there, distributed through the intestinal tract of the chicken. And if the chicken picks up a single salmonella cell, the bacteriophages that are distributed would eliminate this cell and the chicken would stay salmonella free. Yeah. That's a preventive approach. That is all. That is working. That has been shown by many people that it's working.
And can you give us examples in human side, because we are coming from the human side, so of course it is.
Yeah. For a human application, I don't see it as a prevention. Nobody would constantly drink salmonella phages just to prevent a potential salmonellosis. So that would not be a workable approach.
Yes, but some special case, if you have these gut treatment where you build up the microbiome again, you can use also phage as preventive measure to give the new lactobacillus and so on microbiome time to grow up and then to grow better up than the gram-negative part.
And maybe one more application is early, as early as possible, and then you will be still within the frame where the phages work.
Yeah, that's what I was so telling.
So the question was only on the prevention part that you are questioning efficiency.
No, well, we heard also that the efficacy in general there is a question mark, because otherwise we would already authorize as a commission bacteriophage.
It's true, it's not. So yeah,
So that's why also my question, a bit provocative. I
like it because if we should ask the lady that was 3 years in the hospital with antibiotics if that's efficient or not. So obviously
yes, this is an individual case that
Yeah.
gives us some proof.
True.
However, is it enough to go to EMA for a scientific assessment, positive opinion to the commission, and to authorize?
No, it's true, and that's what Dr. Botrogas, when he asked, and looking at the different clinical trials, I always say like this: one clinical trials was one experiment, right? You learn something from that. So as you said, so for one patient it does work, but we have to understand what also it was said, it's not the same as antibiotics, so we cannot treat the same. And sometimes at the beginning they start doing the clinical trials, it's replacement of antibiotic. It's not. It has to be done. It's true that we didn't yet, there's no approval yet, but with all the clinical trials, we learned a lot. So they are much better. So again, I wouldn't say that it's questionable, but we just, in this specific setup, it was not yet fully approved, but it's much better. So I'm not doubting that.
Absolutely, and we are looking forward,
Also.
we are ready to authorize as soon as we have said.
If I may, I'm very sorry, because we need to finish the web streaming on time, and Mr. Bodgros would like to take the floor. I will give the floor to him. We finish officially web streaming and we can continue because the room is still available. Please, Dr. Bodgros.
Thank you very much. I felt, thanks very much for this interesting discussion with Alexandra. So I think we need to stress once again, it's very important to have a pivotal, an ultimative proof of the fact that these products work. And this only can come from clinical trials. I think this is something which we really need to think about. I do appreciate that certain patients, like the one that has been presented, and many others actually, because at the same conferences that I mentioned, there were 2,000 plus case reports of patients over time that have had positive outcomes. These case reports are important and make us believe that this therapy may have potential, but at the same time, there are also cases in which the results were not so positive. And actually, there was one of the speakers at this conference that has shown that the favorable cases were 1 in 3. So around 65% of the cases did not have positive outcomes over time. It may be that this is the patient population, there may be some other consideration, and we need to work together to identify where exactly these products work, in which patient population, and so on, so that we can explain ourselves where they might not work. So I really thought that this is something that we need, to really take away, the fact that we need to work together to have the trials done, to try to understand, to have the proof of concept. I'm almost sure that if the results will be positive, then obviously the interest will grow, also in terms of financing and other aspects. I really thank you once again for organizing this very interesting meeting, and I very much hope that we can work together to progress this matter. Thank you very much in the interest of our patients. Thank you.
Thank you, Dr. Bodgros, and I will allow myself to indeed finish this our debate with this conclusion that we need to work indeed together, and we are happy to work together. So I would like to thank once again all the panelists, all the participants here in the room, but especially our online participants. I think the debate was followed by around 100 people. So thank you very much once again for your participation, for your interest. We will now finish the remote part, but we can still continue discussing a bit in the room. So thank you for the online participants, and for EFSA and EMA colleagues joining us. We will definitely be in touch. Thank you very much.
Thank you very much. Thank you.
Thank you. Bye-bye.
Thank you. Please, yes.
Yes, thank you. So I wanted just to compliment and to respond a bit. Complement what was said and also what the intervention of the latest intervention of EMA. Indeed, we need to work together, and that at the European level in the Commission, we are very much aware of this gap that the regulators are calling for, and the gap meaning efficacy. So proven efficacy will count the data of large scale and not anecdotal data, but data coming from randomized controlled trials of the different approaches that were presented also before. So we are aware of that, and we are considering how to better address this gap so that we are able to move the field forward. Analysis and putting together researchers, regulators, clinicians, so that there are well-designed trials that can prove what is needed so that we can move ahead with the regulatory aspects that are much, calling for that evidence. And that was my points to add in the report. Yes, please.
I would like to add a glance of a positive note. The sense that the vision that was presented by Alessandra, my colleague, the Article 28 in the directive, goes in the direction that these adapted frameworks, this provision is written that in case of peculiar products with peculiar characteristics in methods can have a different regulatory framework. This different regulatory framework should be justified, but it is already written in the Annex 7. But one kind of this product with peculiar characteristic parameters are already understood that can be bacteriophages. So bacteriophages, now we're talking about a proposal of a directive, right? You know that we are in the negotiation process, so we don't know how this will end up. But at the moment that it was proposed in April 2023, this Article 28 foresees that bacteriophages will have a peculiar framework where